Hello everyone, I'm back with a Figure It Out episode. In a previous episode, I had fun in a drifting ride-along in a Hellcat. As you can clearly see, we went on quite a ride with shifts in movement in several directions. You can also see me holding on to the seatbelt. So, as I reviewed the footage to prepare a topic for this video, I thought I'd take a look at what the seatbelts were doing. So, today's Figure It Out question is: a car moving at a velocity of 92 miles per hour, or in metric that would be 41.13 meters per second, slows down to 75 miles per hour, or in metric 33.53 meters per second, uniformly over 1.9 seconds. What average force does the seatbelt exert on a passenger who has a mass of 80.7 kilograms? Now I'm using 80.7 kilograms here because that is the average mass for an earthling who lives in North America. Now, to solve this, we must consider that the work done by the seatbelt is equal to the change in kinetic energy, or delta, KE. Remember, the equation for kinetic energy is KE equals 1/2 times the mass times the velocity squared. Taking a look at the work equals force times distance. Now, the force acting on the passenger, the force on the seatbelt, acts in the, not the force on the seatbelt, the force of the seatbelt, of, not on, of, acts in the direction opposite of the motion the passenger is moving. In other words, that force is in a direction 180 degrees from the motion. And the work done is that force times the distance it took to go from 92 miles per hour to 75 miles per hour times the cosine of 180 degrees. So, looking at what we've been given, just what is that distance? Well, we don't know. So we are going to need to do some extra work, no pun intended. We know our initial and final velocities, and we know the time. We can use our emotion equations to help us because, did I say emotion equations? We could use our motion equations to help us because we can first solve for A and then solve for X. So let's do some work. So you should memorize these three equations. Since we don't know X, we'll start with V final equals V initial plus AT and solve for acceleration. Doing this, we get A equals -4 meters per second squared. Notice the acceleration has a negative sign. That is because we are decelerating, and I think I mentioned that in a previous video about average acceleration. Now, we need to keep this negative sign throughout the rest of the solution. Now that we know A, we can use one of our other equations that has X. So we will use X equals V initial times T plus 1/2 AT squared. Plugging in our variables, we get X equals 70.93 meters. We could very well have used the other equation as well to solve for X. So that would have been V final squared equals V initial squared plus 2A delta X, the change in displacement, or we can just say 2AX. Solving the equation for X and including our variables, that also gives us 70.93 meters. So now that we know what X is, we can continue with our solution. So the difference in kinetic energy 1/2 mv final squared minus 1/2 mv initial squared equals the force times the distance times cosine theta. From here, we can solve the equation for F. Now, we can plug in everything that we know at this point. But remember, the final velocity is smaller than the initial velocity, so we get a negative number on top. Also, the cosine of 180 is -1, so we also get a negative number on bottom. That leaves us with a force of 322.79 newtons, or in pound force, that is 72.57. So that's it for today, friends. Before I go, I want to say thank you to my new subscribers. I appreciate you. I see your comments. Thank you so much for joining in. We're going to grow this channel together. In fact, I want you to let me know in the comments what you would like to see, and I'll add my own little Hellcat Diva flavor to it. And finally, everyone, please keep the racing off of the streets and on the track. I'll see you in my next video.